Okay, today we're going to talk about some Pythagorean triples. So we already know the Pythagorean theorem, right? We know that the Pythagorean theorem says a squared plus b squared equals c squared. And we know some certain numbers that always work in the Pythagorean theorem. So we know, for example, that 5, 12, 13 always works in the Pythagorean theorem because 25 plus 144 is 169. It always works. And what we find is if we were to double those numbers, 5 doubles to 10, 12 doubles to 24, 13 is going to double to 26, and that is also going to be a Pythagorean triple. So we get what we call these families of Pythagorean triples. So you start off with the main one like 3, 4, 5, and then if you double or triple or multiply by 10 or really multiply by anything, you're also going to get another Pythagorean triple. As we just showed with 5, 12, 13, we could double each number and also get the Pythagorean triple 10, 24, 26, or triple it or multiply it by 10, etc. And then here are some lesser known Pythagorean triples. So the first one is to say, is this a Pythagorean triple or not? You have to make sure that you get your C correct, right? Your C is your hypotenuse, your C is your biggest number. And so we want to make sure that we have this set up right. It's asking, is 21 squared plus 20 squared, is that equal to 29 squared? Well, let's see. Isn't 21 squared, isn't that 441? Yeah, I think 21 squared is 441. And then 20 squared should be, what, 400? Is that equal to 29 squared? I don't feel like it is. I got to think about that for 1 second, because do I have that? Let's see. 29 squared. Yeah, I don't think that's going to work. Oh, no, it is. It is. That's actually 841. So it actually does work. Okay, that's good. Pythagorean triple. What about 5 squared plus 12 squared? Does that equal 14 squared? Well, 25 plus 144, that's not equal to 196, so that's a no. And does 7 squared plus 24 squared, does that equal 25 squared? Let's see, 49 and 576, does that equal 625? Yes, it does. So those do work. Okay. Here's the good news. The good news is we're going to skip this section. Oh, isn't that lovely? Yes, we don't do that part about bright, obtuse, and cute. We're just going to go to the distance formula. So the distance formula finds the distance between 2 points. So let's say the point 1, 5, 1, 2, 3, 4, 5. Here's the point 1, 5, and the point 5, 2, 3, 4, 5, 1, 2. And we want to find the distance between them. Well, we can take this and create a right triangle. And we can actually count how high 1, 2, 3 each side is. That side is 3. And then if we count the other side, 1, 2, 3, 4 is 4. And we're just looking for that hypotenuse. Throws 3 squared plus 4 squared is equal to c squared. So 25 equals c squared. So c is equal to 5 there. Yes, the distance is 5. Now that's using Pythagorean theorem, but we can also use what we call the real distance formula. X minus x squared plus y minus y squared. Remembering that in each ordered pair, the x comes first, followed by the y. So if I were to take this same problem that I just did and plug it into the formula, big square root x minus x squared, 5 minus 1 squared, plus y minus y, 2 minus 5 squared. So here I have 4 squared and negative 3 squared, which is 16 plus 9, which is the square root of 25, which is 5. Same answer. So what we call the real formula just really is a shortcut, so to speak, where you don't have to draw the graph. So if we do this one with xy, big square root, negative 2 minus 3 squared, plus 3 minus 0 squared, or negative 5 squared plus 3 squared. Remember that a negative times a negative is a positive, so it's the square root of 34. We can leave our answer like that, or we could type it into a calculator and round it to 2 places after the decimal. So that would be squiggly equal, approximately equal to 5.83. The next one, xy, big square root, -3 minus 1 squared plus -1 minus -2 squared. So -4 squared plus, that turns out to be 1 squared, or 16 plus 1, or 17. And again, if you want to, you could put that in a calculator, 4.12. You've done the distance formula before, so that should actually be a review. And here we have it, more Pythagorean theorem and the distance formula.